Sir, am I audible?
Yes, yes. I'm giving you some question. You do that question, please. Can you try the products? Hello? Hello?
Sir, am I audible?
Yes. Can you write the product?
Okay. So I'm trying.
Hmm.
Concentrated H2SO4, 443. Sir, if you are talking about 413 Kelvin, it should be 2CH3CH2OH, no, sir?
Yes.
But sir, here you have written only one, but I think here
But
two.
that you have to take na. Balancing you have to do na.
Okay, balancing I will do.
Hmm.
See.
Hmm. Correct, correct. Very good.
Four 43.
Hmm.
Alkene with concentrated H2SO4.
You are searching somewhere and you are answering. Not you are answering
Okay.
by.
Sir,
Where
this one
only.
was the final product of the dehydration of alcohol one. So, sir, I wrote this one.
No. This is the wrong. This will be the product of this compound. You are just watching from the book and then you are writing.
I don't
Here,
have the book, sir.
then how can you write the three carbon then? In the reactant only one and two are there, and you are removing the water, one hydrogen from here. This is like that. So it will give simple compound, na? CH2 double bond CH2 plus H2.
Sir,
Here you
I
will.
actually give the wrong product because I think that was for this one. Like one will be one second. This was the third reaction, sir, as far as I can remember. This was again this CH3 reaction, this one.
Okay. Okay.
Third one,
C1.
trying, sir. Third one is the one I wrote, sir. Actually, the third one is the one I wrote.
What will be this one? You write this one.
CH3. 440.
Hmm. Same temperature only.
CH between this.
Only you remove the water molecule. That's it. Okay. Correct. Good. So now we are going from the oxidation. One heading is left. That one we are going to cover this one. Oxidation of alcohol. Oxidation of alcohol. Okay. The oxidation of alcohol involve involved breaking of CH and OH bond. CH and OH bond. So two type of cleavage is possible in this one. The first cleavage is that is CH has to break, and another one is called OH has to break. These reactions are also called if I will write dehydrogenation reaction. Dehydrogenation. H. Removal of hydrogen takes place. Okay. Case 1. Case 1. Oxidation by PCC. PCC. Pyridinium chlorochromate. Oxidation by PCC. Pyridinium chlorochromate. So what their statement is there? It is weak oxidizing agent. So it oxidized 1 degree alcohol to aldehyde. So it will oxidize 1 degree alcohol to aldehyde. Uh, Further, it will not do anything. What they are saying, it does not affect it does not affect carbon carbon double bond or 2 degree or 3 degree alcohol. It is very weak oxidizing agent, so it will oxidize only primary alcohol. So what will be the reaction if I will write CH3 this is going to give double bond will be remain as it is because PCC cannot change the double bond and it will become CHO. Done.
I
Done.
what companies have answered, please and let me know.
So you have to remember PCC, pyridinium chlorochromate. Other oxidizing agent you are taking, they will oxidize to carboxylic acid. PCC can oxidize up to what? Up to aldehyde only. Both are the aldehyde. Okay. Oxidation by CrO3. So we are having the different alcohol. Okay. So what they are saying, if it is the primary alcohol, 1 degree alcohol, so it will be aldehyde. 2 degree alcohol, this is going to be ketones. And if you are 3 degree alcohol, no reaction. Which one? Chromic oxide. This is called chromic oxide. If I will take the example of this one, CH3, CH2OH. So CrO3, it will give the CH3CHO. If I will take the alcohol, this one, 2-degree alcohol, and you are treating with the CrO3, then it will give the ketone. And if you take the 3-degree alcohol, and you are using CrO3, it is not going to react. Why it is not reacting? It is donor group, it is donor group, it is donor group. So this bond are the strong bond. So since this bond is difficult to break, 3 plus I group are there, it will mild oxidizing agent cannot give the product. Done. Hello.
Writing, sir, writing.
Mhm. Done, sir.
Hmm.
Now what we are having, the oxidation by strong oxidizing agent. Oxidation by a strong oxidizing agent. A strong oxidizing agent means what? Acidified K2Cr2O7 or acidified KMnO4. They are very strong oxidizing agent. So what they are going to do in this case? So alcohol we are having, alcohol only. So all the three, 1-degree alcohol. Since it is oxidizing a strong oxidizing agent, so it will give carboxylic acid. The reaction will not stop at the what level? Aldehyde. They will give the carboxylic acid. Suppose you are taking the example, general example RCH2OH, and you are doing the oxidation. So first one it will give RCHO, then again it on oxidation it will give the carboxylic acid RCOOH. So 1-degree alcohol, if you are taking the KMnO4, it will give carboxylic acid. 2-degree alcohol, if you are talking about, it will give ketones. If you use the KMnO4, it will give ketone. And if you are taking this one, 3-degree alcohol, this will give the alkene. Today bio class was there.
No, sir.
Oh, so today you little bit relaxed, I think.
Yes.
Why 3-degree alcohol do not oxidize easily? The reason, if you see here, this is the C, here is again CH3, this is CH3, and we have to break the OH bond. This is donor group, this is donor group, this is donor group. So this bond will be very strong bond. This is a strong bond, and a strong bond can't break. A strong bond can't break. If you cannot break, so no oxidation.
So you have written the O above the arrow, sir. That means oxidation. No,
Yeah, oxidation. Oh, you can write only O.
no sir, not this, sir. That is what I was. Sir, done.
Hmm. Now, dehydrohydrogenation, the last reaction of alcohol. This is what is uh, dehydrogenation. In bracket, removal of hydrogen. This is what is the reaction. Okay. So how you are going to do? So when vapors of alcohols are passed over heated copper at 573 Kelvin, then how it is going to give? Case 1. 1 degree alcohol gives aldehyde. Case 2. 2 degree alcohols gives alkene. No, ketones. 2 degree alcohol will give ketone. 3 degree will give alkanes. So when you are passing the vapor of alcohol over heated copper, temperature is 573 Kelvin. Then it will give the reaction like this. Up now, see the same one. If I will write RCH2OH, this is there. They are saying you have to pass the vapor over heated copper 573 Kelvin. So it will give RCHO. And what will happen here? In this case, the hydrogen loss, this hydrogen plus hydrogen. Asa, second one. RCH, here is OH, here is what? Suppose you are taking R only. So what will happen here? That is copper is there, 573 Kelvin. So here this the hydrogen has to be out. This is 2 degree alcohol. This is 1 degree alcohol. So what it will be there? R. This will be C double bond O. This is R plus hydrogen gas. Case 3. If you take the 3 degree alcohol, 3 degree alcohol we have to take like this: CH3, 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 and here is OH. So in this case, if you are putting the copper 573 Kelvin, so they cannot lose the hydrogen only. So what they do, they react like that. This portion get out. So water will be lost. So this compound will be R, C. Here is CH3 double bond CH2 plus H2.
Done, sir.
Okay. So this is over. Alcohol got over. Okay. Now we are going to study of phenol. We are study of phenol. Here you see this is the study of phenol. What is phenols, Sanay? Phenols? Phenols are hydroxy derivative of benzene. Hydroxy derivatives of benzene. Suppose I am having this is the benzene is there, and you are adding the OH group. One hydrogen you can remove. So what will be there? OH will come out. This is what is called phenol. Hello.
Sir,
So phenols are hydroxy derivative of what? They are the benzene or aromatic hydrocarbon. We are going for the preparation of phenol. There is no more preparation, only the four method are there. Preparation of phenol. First method, if you are talking about first one, from cumene. From cumene. If you go for the second one, from aniline or diazonium chloride. Third one, from chlorobenzene. Next one, from benzene sulfonic acid. So they are the four methods from where you can prepare the phenol. The first method is from the cumene. What is the structure of cumene? This is the, if you can see, here is CH3, this is CH3, this is H. This compound is called cumene. Aniline already you must be knowing. This is the NH2 group. Or diazonium chloride, that is same. From chlorobenzene it will be the Cl. From benzene sulfonic acid, this will be SO3H. So there are four methods to prepare the what? Phenol. So we are going to study one by one. Right. So this is the order according to the importance order. The cumene is the most important. Then aniline. These two last two are not that much important. So we are writing from cumene. When cumene is oxidized, then it gives cumene hydroperoxide. Cumene hydroperoxide, which on hydrolysis So now we can see this is the cumene. This structure is cumene. And you are the oxidizing this one, cumene. You are oxidizing in presence of air only, not you are not taking some other things. So what it is going to happen, peroxide means it will be O, then H. Here it's oxide, it is already CH3 and CH3. Now they are saying you take the H plus. So if you are taking the H plus, what is going to happen? This total compound is going to be removed. This one. So what the product you are going to achieve here? Here will be OH and another will be ketones, CH3, C double bond O, and this is CH3. This is called phenol. Are you listening me?
Yes. Sir, can you scroll? Sir, can you please share me this one, sir, after the class?
Yeah, I'll share, no problem. Next one, we are going from the chlorobenzene. Here you see from chlorobenzene. Chlorobenzene, you already studied this one. Okay. This one you already. When chlorobenzene is treated with NaOH at how much? 623 Kelvin and 300 atm pressure, then it gives sodium phenoxide, which on hydrolysis this reaction you already studied. Suppose this compound is what is something chlorobenzene. Here is Cl is there. Now you are treating with the NaOH. Reaction condition are, that is why the high temperature required, Sannoy. Because there is the partial double bond character in the chlorobenzene. So it will give the intermediate, that is what is called sodium phenoxide, ONA. Then you have to do the hydrolysis, H plus, or acidification. It will give the product. Okay. So when chlorobenzene is treated with NaOH at 623 Kelvin at 300 atm, then it gives sodium phenoxide, which on acidification gives phenol. Now the next one we are having from benzene sulfonic acid. We are having the benzene sulfonic acid. So they are saying benzene sulfonic acid on reaction with NaOH gives sodium phenoxide. Similar reaction. Sodium phenoxide, which on acidification gives phenol. How the reaction you see, little bit elevated reaction we are going. Benzene, you treated with concentrated H2SO4. That reaction from the 11th standard, you will get the benzene sulfonic acid, SO3H. This is what is called benzene sulfonic acid. Now, what we are going to do, you are treating with the NaOH, so you are going to get the sodium phenoxide, and then you acidified it, so it will give the phenol. So directly we can write there, here is the phenol. So this was the third method from benzene sulfonic acid. The last method, if you are going, this is going to form from diazonium chloride.
Sir, can you bit scroll upwards, sir? A little bit. Oh, okay. Done, sir. Done.
Okay, from diazonium chloride. See, we are taking the aniline here. This compound is what is, this is the NH2. This is what is called aniline. Now, aniline can be converted into diazonium chloride by NaNO2 plus HCl. If you are taking NaNO2 plus HCl, 0 to 5 degrees C, so it will give the N2Cl. This reaction already sent me a reaction you will study, N2Cl. Now, this is the reaction is called diazotization. Diazotization process. Of diazotization process, then now you are taking H2O and warming it. Just warm H2O you take, it will directly giving the phenol. But these reactions are supposed to be practiced many times, then only it can be memorized. So there are the four methods are there. Done. Done.
Done, sir.
Next one we are having chemical properties of phenol. Chemical properties of phenol. This is we are having. Okay. So, COH bond in phenol has partial double bond character. Has partial double bond character. Double bond character. So it cannot be break. It cannot be break. And hence it gives only reaction due to two factor. Reaction due to OH bond and benzene ring. So it will give only the reaction due to the OH bond, and secondly it will give the benzene ring. Why the reason? Because of the presence of the partial double bond character. If you see, this is the phenol. So you will find there is, this is going to be this, so this will come out. So what will be happening here? This will form the double bond here. and OH, this will be the positive charge. On the O, here this is negative charge, this one. Once this bond is coming down here, this will be like that. So another structure, if you are making this one, so this is the structure. If you go there, so let us have the look over it. Last one. If you make the resonance hybrid of it, so what you are going to find, that is the there is the partial double bond character is appearing here, partial positive charge. Here it is going to be other places, you see. This is going to be negative, here is negative, this is negative. These are the negative one. Okay, and in the ring also there is positive charge. So here it cannot be break, can't be break. So whatever the reaction you are going to study, due to only two factors. What the factor is, the only one factor is this is the single bond. So it can be break, it can be break, it can be break because of the single bond. And secondly, this will give the ring reaction. So only reaction possible where there reaction possible in this case and reaction in the possible here. But you cannot make any of the reaction, you cannot make the COH bond. Getting my point?
Getting, sir. Getting.
Little bit tough, not that much. So we are going to study the first one. Reaction due to OH bond. This reaction we are going to study. Reaction due to OH bond. First one, acidic nature. Acidic nature. It react with metal to release hydrogen gas. To release hydrogen gas. Just like other mineral acid. Just like other mineral acid. So phenol is acidic. So phenol is acidic in nature. Now, so if you see this one, this we are having the OH, two molecule you can take and you treat with the 2Na. So what it is going to give this one? So this is the ONA plus hydrogen gas. Since it is giving hydrogen gas, so it is the acidic in nature, phenoxide. Second one, neutralization reaction.
Sir, scroll upwards little bit, sir. It react with the. Okay, done.
Neutralization reaction. Since it react with base, base NaOH to form salt and water. To form salt and water. salt and water. So it is acidic in nature. Now, can you see which bond involved? This OH bond involved in this reaction. Can you understand this one? H is break. Yes or no? So these are reaction due to OH bond. Are you getting this one?
Yes.
Here you see this one. You take the phenol and you are going to treat with the NaOH. So here again the bond is going to break here like that. So it will give sodium phenoxide ONA plus H2O. So again it is going to be what type of reaction? This is showing that they are acidic in nature. Other reaction we have already studied, esterification. Of salicylic acid. Salicylic acid means hydroxy derivative of the carboxylic acid. So COOH already I discussed with you. OH is there now. You are treating with the what? Acetic anhydride CH3 C double bond O. This is O. C double bond O CH3. So what is going to happen here? Firstly, you remove the acetic acid from here. This is the side product CH3C double OH plus whatever is left out you can write. This will be aspirin C double OH as it is. O, what will be there? COCH3. This is going to be what aspirin. They ask its name also IUPAC name. Acetyl salicylic acid. So reaction due to OH bond is over. Now we have to study the electrophilic substitution reaction. Done.
Writing.
Now the next one we are moving.
Sir, one second, one second. Last one I was writing. Done, sir.
Now we are studying electrophilic substitution reaction. Sanay, can you join at 1 p.m. today? 1 p.m.
1 p.m. I can join.
So you take break and this electrophilic substitution reaction we will study at 1 p.m. 1 p.m.
Okay.
You call me at 1 p.m. na? Or before you call me 1 p.m.
Okay, sir. Okay.
Because eyes are the started paining.
Okay.